Bright Tuty. Every student matters.
So now, based on this, we will relate the concept of distance. What exactly is meant by distance travelled? What is this distance travelled? What exactly is this distance travelled? First of all, let us see the definition of it. The distance travelled is defined as the actual path covered by an object. The actual path covered by an object. When I mean to say the actual path covered by an object, I mean to say is how much path this particular object has covered. For example, I started moving from this point A and I went to this point B, which is 1 kilometers away from me. Then I changed my direction. I went to this point C, which is again 1 kilometers away from me, and from there I just went to this particular point D, which is let us say 2 kilometers away from us. Right? Fine. So on moving from point A to point B, plus from point B to point C, and then from point C to point D, this is the actual path covered by me. So when I will say that I have been from A point to D point, I will say that on moving from A to D, actually I have travelled a path of 1 kilometers from A to B, plus 1 kilometers from B to C, and from C to D 2 kilometers. So by adding up all these, I will get a total distance covered of 4 kilometers. So I have actual covered a path or a distance of 4 kilometers when I have travelled from point A to point D. Got it? Now, a very important thing that you need to relate is कि this A is my initial point from where I had started initially, and this D is my final position, my final point where I have led to. When I am talking about distance travelled, I have said that from the initial point to the final point, the actual path covered is defined as the distance travelled. But when I talk about as to what exactly is the shortest or the straight or the perpendicular distance, because we say that the perpendicular distance is the shortest distance between 2 points. So if I relate that from this initial point to my this final position, the shortest distance or the perpendicular distance between the initial and the final position is termed as displacement. So when we talk about displacement, we say that it is the shortest distance between the initial position and the final position of the object. The object may be anything or anyone. The initial position and the final position of the object. So that is known as the displacement. And when we are talking about the shortest distance, that means we are talking about the perpendicular distance between the initial object and the final object. Got it? Now we will be studying a bit more about this distance and displacement, but first of all I will relate a separate different concept that you must be either knowing, otherwise please try to relate. When we talk about various quantities or units in physics, right, there are certain quantities which we just relate in terms of numeric values. We only relate them in terms of numeric values, means 1, 2, 3, 4 such values. These numeric values, right, or we say that the amount or quantity or number which is expressed in terms of these numerical values, this is known as the magnitude. So there are certain units or quantities in physics which have magnitude. Let us take an example of it. For example, if I talk about time, right, I will ask how many minutes, how many seconds, how many hours, right. So the magnitude indirectly gives us the answer of how many in terms of numbers. For example, 10 seconds, 20 minutes, 10 hours, right. So I will say that time is a unit which basically has magnitude. Got it? Fine. This quantity time has got magnitude. Similarly, when I talk about length or height of anything, maybe length of a road, maybe length of the floor, length of the wall, or height of the wall, or height of a person, or height of a building, whatever. So whenever I am talking about length and height, once again I will be asking how many meters long, or how many kilometers long, or how many meters high, right. So once again the quantity length and height have got the same thing, that is the magnitude. All such quantities which have got magnitude, we term these quantities as scalar quantities. So what are scalar quantities? These are the quantities which have magnitude, right. They are known as scalar quantities. Got it? But there are certain quantities which, apart from the magnitude, they also have got one more thing. So those quantities which have magnitude as well as one more thing, and one more thing is direction. That if the direction is also specified, then in that case those quantities are known as vector quantities. We will study a few examples in detail. Right now I am just giving you the example of vector quantities. One is displacement. Displacement is a vector quantity. How? We will just study right now after 2 minutes. Another thing in vector quantities is velocity. What is velocity? Why it is a vector quantity? We have got the details in the same chapter only. We will study it. Don't worry. Fine. Right now we are concerned with these two terms. One is scalar quantities and one is vector quantities. What are these? Those physical quantities which have got magnitude, the amount only, they are known as scalar quantities. Whereas those quantities which have got magnitude as well as direction along with them, they are known as vector quantities. Got it? Now coming back to what exactly we started with distance and displacement. Let us study a bit more about that, keeping in view these scalar and vector quantities. First thing we talked about distance. The second thing we talked about displacement. Now try to relate both the things once again by taking yet another example. I say that a body is in motion. That means the body is moving. Now when we talk about the motion of the body, we are talking about whether the body is moving in a straight line. If the body is moving in a straight line, we say that it is a linear motion. Linear is motion in a straight line, right? Otherwise the body may also move in circles, then we call it a circular motion. There are different types of motion basically. We are more concerned about this linear and circular. It may be rectilinear, it may be curved, all types, but we will be studying about the straight line motion, which is the simplest type of movement and motion that we observe, or the motion of a body in a circular path later in the chapter, right? Alright. So, right now I am taking an example of a linear motion. For example, straight path, there is a straight road and I move from this particular initial point which I term as A. Fine. Now, from A I move a certain distance. Let us say I moved 2 kilometers to a point B. From this particular B point I move yet again to another point C, which is, let us say, 25 kilometers away from B to a point C, and then from C I will move to a point D, which is, let us say, 2 kilometers away from C, right? Fine. Now, I had some work at this particular point D, and after D I again came back to point C. Fine. Now, when I am talking about the distance travelled by me, try to relate please, I am repeating it again. I travelled from A to B to C to D and then back again to C, right? And here I just rested. Now, if I talk about the distance travelled from A to C, then the distance that I have travelled is, initially I travelled a distance of 2 kilometers from A to B, then again I travelled 2.5 kilometers from B to C, then I travelled 2 kilometers from C to D, and then back again I came to C travelling a distance of 2 kilometers. So, if I add them all, I travelled a total distance of 8.5 kilometers from A to C. But when I talk about displacement, what did we learn about displacement? That displacement is the shortest perpendicular distance between the initial position and the final position. The initial position was A and the final position was C, regardless of whether I have come back to C from D, but final position is C. So, if I am talking about final position to be C, then the displacement will be the shortest distance between A and C, which comes out to be 2 kilometers, this one, and 2.5 kilometers, this one, just 4.5 kilometers. So, this is the concept of distance and displacement. I hope now it must have been quite clear to you guys, right? What exactly is the difference between distance and displacement, calculation wise, taking an example. Fine. Now, let us see the actual differences. Theoretical wise, if we get in the exam, how we are going to differentiate between distance and displacement. Students, whenever you will write differences between any two things in science specifically, first of all, the very first difference should be their definitions. Always try to differentiate between two things by defining them first. So, as per the definition we saw, I am not writing it fully, I am just giving you because I have written above. Distance is actually the actual path covered by an object, you have to write in full, okay? Whereas displacement is the shortest or perpendicular distance between the initial point and the final point, or initial position and final position. Now, I have written BW between, you are not going to write like this, IP and FP. Being a teacher, I have written it. You are going to write properly and thoroughly, fully, right? Initial position and final position. Got it? Now, this is the definition difference between distance and displacement. Second important thing is that distance is a scalar quantity. Whenever we talk about distance traveled, we'll always ask how much, how many. How much distance did you cover? How many kilometers away is your house from my house? How many kilometers away is the airport from your house? Right? How many kilometers away is your school from your house? So, it's always how many. Whereas, when I talk about displacement, of course, if we are differentiating between them, it should not be, of course, scalar quantity. It has to be a vector quantity. And when I am talking about a vector quantity, I am saying that first of all, how many kilometers, right? And along with this, I need to know the direction. And when I mean to say direction, then what term we have used? It is the shortest or the perpendicular distance. Fine. So, I need to draw perpendicular. So, if I am talking about this position A and this position D, I can't go or deviate in any other direction. I just have to draw a perpendicular between these 2 points. Fine, right? Rest also we will take a few examples when we will be doing the questions as to how we will represent this direction part in displacement. Fine. Now, the third difference between them is the distance travelled can never be 0. It can never be 0. If I have travelled any path, it has a particular value. It can never be 0, but displacement can be 0. Now, this is very important that you need to relate. What we have told is that displacement is the shortest distance between the initial point and the final point. Fine. Let us take an example that I started from A, I went to B, I went to C, I went to D points, and then I came back home or to my initial point A. Now, the initial position from where I started was A and my final position is also A. And the distance between my initial position and final position, which we termed as displacement, is actually 0, right? Because the initial and final positions are same. Fine. So, I will say that my displacement will be 0, and when this will happen? Displacement will be 0 when the initial position and the final position are same. When we are talking about a particular object travelling from a particular point, initial position, and going through, travelling a path, whatever path it is taking, but if it comes back to the same initial point, then we say that the displacement is 0. Got it? This is very, very, very important to relate. Now, this thing we may also relate in another example. Let us take, I go for a morning walk in a circular park. This is a park which is circular in shape. Let us take an example that I entered the park from this entry gate A. Fine. I will start walking or jogging or running along this circular path. Fine. And by completing one whole part, I came back to point A. I am panting, I am breathless, I have done a lot of work, I have just had a lot of sweat. Fine. I have covered the whole path. This is my distance covered. But when I talk about my displacement, Once again, my displacement will be 0. Why? Because my starting initial point was A, and after covering the whole area of the park, I came back to the same point A, which is again my final position. There is no distance between initial position and final position, so I will say that my displacement is 0. Got it? Now this is a very important question that comes in your exams. Let us try to relate. Will be given that there is a circular park. Fine. We need to calculate the distance travelled and the displacement if I complete one full round of the park. Displacement, we have just seen that it is 0. Fine. What about the distance? Distance is the actual path covered, and when I talk about the actual path in a circular motion, what I will say that it will be equal to the circumference of the circle, and the circumference of the circle I should know that is equal to 2 pi r. Right, it is 2 into pi into r. This is circumference of the circle. You must have studied area of circle pi r square, circumference of the circle 2 pi r, where pi is a constant whose value is 22/7, or we may also relate it in decimal form as 3.17. It is a constant value, and r is the radius of this particular circular park. This is the radius. Whichever value will be given to us, we can just put the value here. If we are said that there is a circular park whose radius is 50 meters, right, and we took one complete turn of that particular circular park, what will be the distance travelled? We will just put the value. We know that circumference is equal to 2 pi r, which is equal to the distance. That will be 2 into 22/7 multiplied by r is given to me to be 50 meters. I will just calculate the answer. Whatever value of radius of circle is given to me, it will be replaced by r, and we can calculate the answer. Right? Fine. Alright. But when I am talking about the displacement in one complete round, it will be 0. Got it? Fine. Next question which may come with the same concept is, what if I have taken a half turn? If I have taken a half turn, means I have started from this point A and I travelled half of the distance and I came to this point B. Now the things will change a bit. How? When I talk about the distance travelled, I have travelled from point A to this point B. This is half of the circumference. So the total circumference was 2 pi r. Half of it means it will be pi r. So if I have taken a half rotation of the park, then my distance travelled will be pi r. What about the displacement now? Will it be 0? No, not in this case. Why not in this case? Because now we have got point A and point B. Displacement is the shortest distance between point A and point B, which I can relate to be this perpendicular distance, and if I relate, this is the diameter or radius. This part is the radius, this is also the radius. So if I am taking half a rotation, then I can say that the displacement will be r plus this r plus this r, that is 2r, right, twice into radius. Got it? This is quite important that you need to relate. Fine, right? So this is our distance and displacement concept. Now whenever we are talking about distance and displacement, both of them are measured in SI units, meters. Meters which is represented by small m. That is the SI unit of this particular distance as well as displacement. Got it? Fine. Now, when we talk about other units, we must know that there are other units too. For example, if I take a smaller unit, that smaller unit is centimeters, right, which is expressed as small c small m. And if I talk about the bigger unit of distance and displacement, it is kilometers. Kilometers represented by km. So, these are the units that we will be using. It will be centimeters, meters, kilometers. There are other many units also, millimeter and picometer and femtometer and megameter, etc. But we are just restricted to these three particular units. We limit ourselves to these three units only. The SI unit, that is meters, one smaller unit, that is centimeters, and bigger unit is kilometers. And we must know the relation between these two. We know that 1 kilometer is equal to 1000 meters and 1 meter is equal to 100 centimeters.